Okay, so I sort of came out of my turkey coma on Sunday and realized that I needed to put together slides and thought, how am I going to put things on the screen so that people can see them and make slides? There, I just figured that out. If I can't hear me, nobody else can. Okay, thanks, Jordan. And then it sort of dawned on me that, well, I'm going to give a talk about Flutter, and the whole idea of Flutter in particular is to put UI things on the screen and to make them attractive, which I'm not going to claim I've done, but put them on the screen. And so what I did was write this app so that I could just go through my bullet points. And it turns out that's handy because, particularly handy, because here's my phone. Now you all know the password. There. And you can sit wherever you are and work on your talk while you're doing other things. So it's really pretty handy. So basically what I have up here right at the moment is the simulator, the iPhone simulator that's running on this laptop. And then my phone is just being shown on this screen using Visor, which is a really nice little app. Okay. So can everybody see those bullet points? Is that okay? All right, good. So first, just a little bit about me so you know where I'm coming from. I started writing code when I was in middle school and then went to, I didn't start writing code in middle school because when I was in middle school, you punched cards. Every operation was a punch card. And you put them in order, and you carried this stack carefully to, the person who read that into the card feeder, and then you came back the next day, and if the really did print out, this thing you've been waiting for, which was normally 42, then it was like, wow, the universe has spoken, I can program things. So I really got hooked on programming then, didn't do a lot during the years, went into a research career, and started in graduate school programming whatever needed to be programmed in the lab using whatever language in order to make the sort of data capture, data visualization, all those things as efficient as possible. And so we used a lot of different languages through the years. I had a molecular genetics research lab at OMRF for 24 years, and that's where I did most of this programming. About 5 years ago, left the lab, went to a small company, did C++ programming for the back end, which I've suddenly found was not that much fun. Because in the lab, what you do is you work with graduate students and technicians and postdocs, and the idea is to make everything that operates in the lab as fast and efficient as possible. And you get to have a really quick turnaround for how well you're doing with user experience. And it matters to you as the head of the lab because you really want the whole thing to move as fast as possible. So I didn't realize it at the time, but I got hooked on UX and UI. So I left that company after a couple of years and went to work with Headstorm Studios, which is a company here in Oklahoma City. It's a family-run company. It's my family, not me, but my daughter, who's right there, and her husband and other programmers were there at the time, and they were writing mobile apps as well as doing websites and that sort of thing. So I jumped in, learned Java, learned Android, wrote an app, put it on the Play Store, and working with Emily to keep that in sync was kind of difficult, and if you've done that sort of thing, trying to keep an app on two different platforms moving in sync, you'll understand how hard that is. But it was okay. But if you program for Android, you have my sincere apologies. It is not an easy platform to program in. So I moved on to another app that we needed to write. Wanted to do it as a cross-platform app. So this is a little over a year ago. Did my homework and came across Flutter, which had just sort of hit the public awareness. It was an alpha at that time. So I did a lot of homework. Flutter uses Dart as the language. Read all kinds of terrible things about Dart. Did a little more homework. Decided it was probably worth taking a chance on. Okay, so for the past year, for this particular project, because I have other things going on, but have used Flutter to develop an app, and it's out on the Play and the App Store as well. And I have to say that it is really much more fun to develop in Flutter than it was in Android. And I'm going to, so today, do really 4 things, and I'll try to do them fairly gently. I have to introduce you to Dart, the language, and just a few things, then tell you about the Flutter SDK, because it's not a platform, it's an SDK. Then I want to go to what this group is all about, which is functional programming, and just a couple of sort of major areas where that's been brought into the app development world, mobile app development world, to handle state, because as everyone knows, state management is always a chore, okay? And especially in a mobile app, because you have the user interacting with the phone, so that's changing state. You normally have streams coming in from outside, and that's changing state. And how you put all these things together, maintain state, and have it ready to persist at any time, because the phone may get turned off, battery may go off, whatever. But also present it to the screen in a timely manner, present it to the user. That can be really hard. I'll say up front that Redux, which is sort of a major outline or approach to managing state, is fairly heavyweight, okay? And the usual advice is don't use Redux unless you really need it. And I think now that I'm getting a little more used to it, that I'll probably turn that around and say, you know, you learn Redux so you're comfortable with it, so you can start with it, because it scales really well. You don't wind up with these awful messes of not knowing where things happen once you get used to it. And RX, Reactive X extensions are just kind of tricky, and so at the end of the talk, if there's time, I'll go through a few examples of that and how it's set up. Okay, so one of the charms of Dart, of Flutter, is this. So here's, I think you can see at the top there, this is my email address if you want to get in touch with me. But you don't need to see that for the whole talk, right? So I can go, so this, like I say, is running in debug mode right now in the simulator. Ruh-roh. And we're off to a start. I might have to restart it. All right. Oh, that might actually be the reason it had actually stopped. Okay, so let's wait for this to come up. And I know that I was tempting the demo demons from the word go, because trying to keep 2 different sort of phones and a laptop going, and I'll show you the cloud as well, can be kind of a chore. Okay. So I'm going to have to tell the phone that it's turned. There we are. All right. So now, go into the IDE, and I can hit find, basically, go over here. You can see where the code is in the background of the slide. If I type on that, now it's taken me directly to that place in the code, which is nice, especially if you're a designer trying to design or change the design that some developer has handed to you. But you also see in here the widget tree that leads to that particular UI element, okay? Flutter is all about widgets. It's widgets all the way down. You build widget trees. Everything is a widget, including the app. And widgets tend to be small little, well, for the UI at least, small little descriptions of what you need to do for whatever. So it can set padding, it can set boxes, it can set text, it can do those things, and you can wrap them. So here what you're seeing is the evidence of that widget tree that leads to here. Okay, so enough of that. Turn that off. I'm in the code where I want to be. So a more appropriate title, oh, I just realized what I need to do. And I should say, anybody wants to break in at any time, please do, because the whole point of this is to inform you. Yeah, and I was going to say what I just realized and then looked up at Jordan is that you couldn't see that. So if things like that happen, don't hesitate to jump in and tell me, okay? And I should say, this is the first programming talk I've ever given, and I've stuffed the audience with family and friends, so if you see something stupid, by all means, feel free to say, well, that's stupid, and it probably will be, and you may as well, because family and friends always point out to me when I'm being stupid. Okay. Yes? Are you ready? For what? For the onslaught. Family. See, I told you. Okay. And what is Redux? What is that? What is... That's part of the talk, and we'll get to that. And then Dart, is that the language? Dart is a language, and that's the first part of the talk. Well, all right then, we're on that. Okay. See, and I didn't even like get testy about that. Okay, so you're safe. This is a safe environment. I want it to be a safe environment. All right, so what I've just done is change the code. You know this is running, it's in debug mode. You know that this is at the bottom of a long widget tree. I can even like start to scroll, so I'm changing state inside the app. But I can go now to hot reload, and there it is, okay? So it's a stateful hot reload. So if you're developing a form, you can be numbers of widgets into that form and say, oh, I don't like this, I want to move that over by 2 pixels. You can go in and change that, hit hot reload, see how it looks, and keep going. And that is a charmer if you've ever had to do this sort of thing. Okay. Is the IDE Android Studio? You can do this in Android Studio. I'm using just IntelliJ straight out with the Dart and Flutter plugins. A very popular IDE for Flutter developers is VS Code. And it actually, I almost used it instead because it's got a few things that I really like in an IDE. But if you're trying to choose and you're a student, nice thing about IntelliJ is they have basically IDEs and plugins for a lot of different languages. And if you learn the hot keys, then you can use those no matter what you're programming in. So that's basically why, but VS Code may do the same thing. And I should say, if I didn't say it before, I may have, that I really think of myself as a beginner on this stuff because I've only been doing it for a year. And so if you have better ideas, by all means, bring them up because as Elizabeth, my other daughter, just said, there are a lot of students in the room and the idea of this is a lunch and learn, not a, lunch and confuse. So by all means. Okay. So, on with the talk. I want to start with Dart and say a little bit about it because it's not what it once was. If you had learned about Dart 7 years ago or so, it's when Google was trying to take over sort of the web programming market, take it away from JavaScript. So Dart was meant to be an alternative to JavaScript. As a result, there's a Dart VM to run in browsers. It's just-in-time compiled. It's dynamically typed because that seemed like the thing that people would want to do at the time. And basically, they failed. JavaScript took off, and they failed to gain any market share. And so Dart wasn't used anywhere except inside Google. In the last couple of years, that has changed. And so when I was doing my homework, trying to decide how to do cross-platform app development. It was clear that inside Google, Dart was really expanding, and not just because you had to because you were at Google, but because it was sort of the language of choice. And that's because the language itself was being developed. So version 2 of Dart is now out. It's strongly typed, so type inference works well to save you if you really don't want to have to enter all those characters when you're writing the code. But it supports futures, and futures are essentially promises if you're coming from the JavaScript world. It has the async await pair of keywords so you can program in sort of an easier to read style. It supports generics, functions are first class, streams are built in, and those two things are big, and it has really fast garbage collection. And that's important for Flutter because of that widget tree. If you have to rebuild a screen starting at the base widget, you've got a lot of changes to make. And the promise of Flutter is that you can do smooth animations. And smooth animations means 60 frames per second or better, okay? So it has a lot of things that it needs to garbage collect, especially during animations. Okay. Now, Dart is an object-oriented programming language, and so it might seem odd that I'd be standing up here talking about functional programming, but functional programming ideas and concepts, perspectives, really add so much once you get comfortable with it, and that's obvious also to the Google developers. So for one thing, they provide code generation packages. So if you want to have a value class, which is not sort of inherent in Dart, you can make them easily using a package called built value. And I'm not going to show you that. If somebody's curious, I can show you an example where basically you just tell it what you want your class to look like. You run the code generator, and it's there. And what you've written in 50 lines or 40 lines turns into 300 lines in a generated file, but it's completely, it's transparent. You don't even see, you don't have to think about that generated file. You just get to use it. Another thing, and this is true, I think, for Kotlin, they're very happy about enum classes. Dart had only enums. Well, with these code generation, it's easy to build and handle enum classes, and I've used them actually in this code, and serializers. Serializers are meant to be more flexible than typical, so you can plug in that you want to serialize to and from JSON, and it'll build that for you. But you can plug in that you want to use XML, or you can plug in some other format. And in fact, Google prefers using a list-based JSON rather than a map-based JSON. Apparently, it's better behaved over the wire. Again, you don't have to think about it. You just run the code generator after you've started showing it what you want to have built, and you're done with it. So the bottom line is that Dart is actually a very friendly language. I came to it from Java. If you write in JavaScript or Java or C#, or Swift or Kotlin for that matter, Dart should be very, very familiar. It should be easy to read. And I'll show some examples here pretty soon. Okay, so there's no good reason, I think, currently, other than just it's another language to learn, not to learn Dart. It's not like having to go back and learn some awful language, which I won't name. But you can all guess. So why not use Flutter? And there are a lot of reasons out there for not using Flutter, but most of them are out of date. When I started, Flutter was in alpha. Now Flutter is in beta, so its version 1's not even out yet, but Google has a Flutter live program planned for next week, and so it will probably be version 1 as of next week. So there's no reason to worry about that. Flutter is an open source software developer kit. That is, it's not a framework like Android or iOS. It's actually like a game engine, okay? So it draws directly on the canvas, and it takes that game engine with it when you deploy an app. So it works on old versions or new versions of Android or iOS. In fact, Flutter, I don't know if you know about Fuchsia. Fuchsia is Google's new operating system that's supposed to do everything, run on IoT, run on laptops. And I would have, a week ago, said Fuchsia is still in development and isn't used, but last week it got deployed on phones in China. So it is being used, it has been deployed, and Flutter is the supported mechanism for drawing UI in Fuchsia. Since it is like a game engine, it can be embedded anywhere. 2 weeks ago, a venture started up and offered to people like me who showed interest early on to upload their apps, where now they do a little bit of massaging, wrap it basically in an embedder, and so now you can run Flutter apps on Mac OS. Windows is next. Those are not Google-supported ventures, but it just sort of gives you an idea that the Flutter SDK, especially with that embedded engine, is very flexible, can be used anywhere. And so if you're thinking about learning some new app development thing, say in weekends or whatever, I don't think it's going to go away, okay? And it may be a lot more flexible for the future. So I said it was built for animations and the 60 frame per second standard, and that's because Dart is not any longer limited to being just-in-time compiled or transpiled to JavaScript. Release versions for Flutter and for Dart, of course, are ahead of time compiled. Okay, it has a nice tree shaking compiler, so you don't have to worry about minimizing your imports and all that sort of thing. And it's compiled directly to ARM binary code, so it's actually native. Okay, it's just not like these other things like React Native, where you're actually working across a bridge the whole time, but you're drawing things to the screen and taking things from the phone. Okay. One of the nice things about using the approach that they've used to drawing widgets on the screen, or using widgets to blueprint the screen essentially, is that it makes it really easy to do UI branding. So there's two sides to this coin. You would like to have your company brand be obvious and the app be easily used by the same people, whether they're on iOS or Android or whatever. But sometimes you really, your users expect it to look like iOS or like Android. It has built-in iOS and Android widgets, okay? So you can use Cupertino widgets, or you can use material design widgets, but you don't have to use either one of those. And so you can absolutely have it look identical on different phones. The other side of the coin to that is iOS people especially want it to look like what they're used to, and they're used to the way things look on an iPhone. So you can do it either way. I guess that's the good thing. You actually have the chance to do it either way. So the reason that that hot reload that I showed you is available basically is based on Dart's bad history, right? It used to be just-in-time compiled. It used to run in a virtual machine. When you're running in debug mode, it's running just-in-time compiled in a virtual machine that you're talking to across the, from the IDE to the simulator or emulator using a local socket. So those of you that have gone through Gradle builds with Android understand that you're going to wait a while if you have to go through a full rebuild. When you're doing this, there's no Gradle involved. Another button that I didn't show you is hot restart. And there, basically, because you've already loaded the Dart VM on the emulator or simulator and gotten it fired up, you can have a stateful reinitialization that only takes a couple of seconds. So again, speeds up the development cycle, and that's always a great thing. I'm not going to talk about this. I'm not going to talk about that because we don't have time. Testing is well supported and built in. And Flutter has been picked up. Alibaba, which has 50 million, I think, mobile users, their app is written in Flutter, okay? And so big companies, Google AdWords mobile app is written in Flutter as well. And in fact, AdWords is written in Dart, and that's how Google makes their money. That's their big deal. Okay, so again, I don't think Dart and Flutter are going to go away, and that is certainly back in the alpha days, even through the beta days, was something of a concern, but you know, you pays your money, it takes your chance. Okay, so that's Flutter, enough. What I want to talk about next is Redux, okay? And as I said, the problem with phones is largely that, well, with many apps, because Redux began in the website business, or web app business, is how to handle state when state can be changed in a bunch of different places, and it becomes really hard to reason about as your app gets bigger and you have connections here and there, and it's hard to know who is changing what. So the idea of Redux is shown in this diagram. So let's start at the bottom. No, we'll start it over here on the right with the store. The store holds all the states app. Now, what's great about that is if you know that you're going to have all this app state collected into one place that's immutable when you start writing the app, then it really forces the discipline of thinking, gee, what state are we going to have by the time we get to the end of this that we're going to want to be able to persist and to keep up with. So I actually like this, the fact that it forces that discipline on me, which actually I hate that it forces that discipline on me, but it does, and that's good in the long run. The store provides the updated model whenever that comes in to the view, so the screen or the page, which is going to show whatever state it needs to show, but also give you a way to interact and change the state with buttons or whatever. When you push a button, for example, to change the state, that fires an action, okay? And an action is just a class of a particular type so that you can sort out on the other end what that type is, what the action is, and it can carry a payload. Now, if you don't get this, don't worry, I'm going to go through it 2 more times, okay? It can carry the payload and tells the middleware what to do. Now, you don't actually have to have middleware, okay? The action can go straight through the reducer if it's a really simple app, and the only state change comes from pushing buttons or filling in boxes on the view, okay? Because then it can go straight to the reducer, which takes the updated state, turns it into the model, sticks it in the store, and now the store informs the view that the state has changed. Okay, that's the way it works. The middleware is actually where all the interesting part happens, and it's where all the hard parts happen, okay? Because that's what deals with all the different pipes coming in, and the middleware is responsible for talking to outside the app, okay? So, for example, making calls out to the web, whatever might have, what you might have as a back end. Okay, so basically, what I want to do now is lead you through a particular Redux application, all right? And this I actually drew from Andreas Bizotto, who did an example app showing 4 different ways of handling state. This is just the Redux one, but it's real, I really liked it, and so that I'm going to borrow it. Okay, so what you can see here is basically there's a counter. I can add a plus or a minus, tap a plus or a minus button, and the number beside it will change. Okay, not too exciting really. I also have up, though, Cloud Store, which is a Firebase offering from Google, which is a cloud database, all right? So what you'll see is we have this, well, I don't think I can make this bigger. Oh, I can. Yahoo. Okay, so this is actually looking at this database in the cloud using my console, okay? And let's say if we want to look at number 88, the counter that's identified by 88, that's this one. Well, go back over here. Its value is 2, now it's 1, okay? So what's actually happening is when I push plus, it's firing an action, goes through the middleware, goes up to the cloud, changes it, the state change comes back, it goes through the middleware reducer, changes state in the store, store tells the screen what that is, and it updates it. Okay. And if you have another, say, phone running the same app, then it should stay in sync. Okay? So in fact, if I change it here, yeah, good. Whew. Not just enough of a delay. Be still my beating heart. Okay. So it gets the updates as well, and of course you can fire it in the other direction. All right. So that all works, bottom line. So how does that work really is the issue. Okay. I don't think I'll use the find approach again because it's just not necessary. So I'm going to go back into the IDE and back to where all that is set up. Okay. So you see this tab bar along the bottom that I use to go to that. I can go to the other screens in the app. Where this screen is set up is when I type on this Redux tab item right here. Okay. Whoops. So what happens? First of all, it sets up the database. That's the first line here, right? It sets up the stream or gets a reference to the stream that's in the database. Again, I'm going to go through this more than once. And puts those in the middleware. So this is where the app is going to talk to the Firebase cloud store and get the information back, okay? Then the store is set up. It's set up with the reducer. Now remember, the reducer is just that last thing that happens before you go into the store. And really, and this threw me for a bit, but the reducer is not much different from the actions that act in the middleware. It's just the last one, and it has the responsibility of returning the updated state model to the store, okay? So it's not too magic. That gets passed in, the initial state, the middleware, which was set up here, it gets a reference to that, and now the store is set up. There's one more thing here that's hidden from view, and that is I've also used Flutter Redux package, which links up the widgets of the store to the screen widget, okay? And that's done by a stream in the back end, so it comes through, all right? And the middleware is set up specifically to listen to that stream, and that's in this line, and use the store, which actually dispatches all the actions. Okay, that's kind of a detail, but it's important if you ever want to do it. And then here is the Flutter part of the Redux. That is, the store provider is going to provide the state, which is in the store, to eventually the page. And like I said, this is the page. Okay, so that's what it's going to do. So what I want to do is track this increment counter, the path it would take through Redux to get back to the view, actually. So I need to go to the Redux page, line 120. And you were saying, why aren't you talking, Mike? Oh, no, line 20, not line 120. There we go. Okay, sorry. So here is the declaration of, or description of the increment counter action. As I said, it's just a simple class that can carry a payload. In this case, one of these counters that's shown up on the screen. All right? And when the button is clicked, it calls this onIncrement method, which is on line 132. And okay, so here it is, right, on increment, and it's calling back to this function, increment. And now you see what actually happens. That is, when that gets fired, it sends the store and this counter that it's looking at with the counter's local state. The store dispatches that increment counter action, and the payload is a counter, okay? So this dispatch means it's going to be sent into the middleware. So when the store, when Redux actually gets set up, basically it looks at all the different middleware that you might have, and it routes any action through all of those different pieces of middleware. There's just one piece of middleware here, right? And then at the end of that, routes it to the reducer. So all that's handled sort of on the back end. So this increment counter action is being sent into the middleware. And now we hope that I can find it. Okay. All right. And this is where it's going to get handled. So this is in the middleware, okay? It's called, because this is a callable class. And the action, if the action is increment counter action, which it is, then it's going to call the database and set this new counter. I know this gets roundabout, but that's the way it works, okay? So what does set counter look like? Here's set counter in the app Firestore, which is the implementation of the database, which is abstract. This was set up early on. The counters reference, okay, is, I think, just below. Right. Okay, it's going to call counters reference with set data. And basically, that's the connection between the database and the store. Okay, that actually is what gets sent to the database. All right, how does it get back? It gets back via this stream, which was again set up when this page actually was first loaded. So this is a stream that comes in from Cloud Store. It's the Firestore stream, right? You don't need to worry about that. That's what localizes this particular place in the Firestore, in Cloud Store, Firestore database, okay? And when that stream fires and comes in, it's sent through this parser because it comes in across the wire, and this is where you need to parse it into something, into an object that you can actually handle, okay? And all that is a stream that's called counter stream. And if you remember, counter stream was what was first passed in to middleware when we were first setting up this page, okay? So what happens when counter stream hits the middleware? Okay. So the counter stream at this point is just called stream because that's just the way that it came in. And so somebody had to call listen at some point that says, okay, you're going to listen to that counter stream, that's what's right here. You're going to get counters because what actually comes back from Cloud Firestore, there we go, wow, is all of the updated state because all of the state is actually, in this case, held in Firestore. And when it happens, then store is going to dispatch this update counters action, okay? And that's the one that then actually gets handled in the reducer. Okay, so the reducer is now going to, if the action is the updater counters action, then you're going to return the new model. And the model in this case is really it just holds this list of counter objects. Yeah?
Did you say it's going to return all the counters or just the counters that have changed?
In this case, it's all of the state at once. Okay, because again, basically the idea, and this is a functional programming idea, I guess, is you're always dealing with a mutable state if you can at all. So you never actually would just change one thing, you would create a new whole object that carries that state with the change in it. And one of the things that really helps about, especially when you have all this asynchronous stuff going on, is that you never have to worry that you're going to be out of sync within all of your state. It represents good state, at least at one point in the running of the program. And like I said, that especially gets tricky when you have all this asynchronous change. So it just really helps to reason. And that's, again, built value that I talked about early, which is a way of, in Dart, making immutable objects, provides a builder function so that you can just say, okay, this is just like, I want a new object. It's just like this one, but it has this one change. Okay, so you don't always have to enter all the new changes in your code, just the one change. But what you have not done is mutated the old object. You've created a new one and passed it on. Okay. All right, so the model now is passed to the store, and the store is going to get this new model, and as soon as it does, I'm not sure I can do this, but we'll see. I think this might take a bit of time, but again, since this is all open source, you carry the source around with you on your laptop. And so in the middle of programming, if you're not quite sure what something does or uses or what the parameters are that it takes, you can just, in this case, command click on it and it takes you to the source code. And I will say this about Flutter, they have been great about documenting the source code. So it makes it really easier to, as easy as possible, I should say, to understand what different classes or functions are actually doing when you don't already know. So I'm going to bag out of that. So what you've seen, what I've taken you through in laborious fashion, is what happens when in the view, you click on the increment button, it fires that action, goes into the middleware. Middleware knows to route this off to Firestore. That comes back with, what that does is update the state in the Firestore. All of the updated state comes back in a stream to the middleware. It calls the reducer finally to turn that into the model object, puts it in the store, and the store tells the view. Yeah?
Are each of these happening like as an asynchronous event?
Yes, right. And just in case you go out soon and start looking up Flutter for whether you might be interested in it or not, an article came out about well, not an article, it was in the Reddit Flutter dev group that linked to, well, an article saying, oh, but if you look at Flutter and you look at the issues, you'll see that some issues sit around forever, and one of the problems is that they won't even handle synchronous callbacks from, or synchronous, I guess callbacks, from the Android or iOS platforms. And that was completely screwing up some developer that's what he really worked on. And the problem was that the Flutter team at Google really doesn't like synchronous code at all. They want everything to be asynchronous so that nothing ever blocks. Okay? Yeah?
So will the GUI not update until it makes it all the way out to the connection back around?
That is absolutely right. But I have an answer for that as well. No, yeah. In a more complicated app, so if you were worried about the user experience, right, basically what you would do would be update the state locally and then give the user that immediately and then shunt that off to send it up to the cloud and save it.
So that local event kind of goes through that chain of stuff as well, just kind of split off before it gets, like is it a different middleware basically that
Right, that's right. That's right, yeah. The middleware really is where all the mess happens, right? And it's nice because it's all in one place. Okay. Yeah? Sure.
Most middleware implementations you see on other platforms allow for multiple pieces of middleware to be stacked in sequence.
That's right.
Together. This is very much.
Absolutely. So in fact, what you would do is, I'm sorry, absolutely. See? Yeah, I have to be told these things. I knew I did. The question was that in other systems, middleware can be stacked. And can you do it here? And the answer is yes, absolutely. Here's where you would actually do that. So this is in the place where this page was being set up, okay? And middleware was instantiated in the line here, right? And then it's passed into the store that's going to handle all the dispatching of the actions through everything. You'll notice this is actually a list, and so that's where you would add all the middleware. And you would add it in the order that you wanted it to be used, basically. Because what's going to happen as the store is set up is it sets up that routing through everything and then actually then flips it and puts the reducer at the end. Okay. Any other questions? Sir?
Are you using like a Redux Dart binding?
Yeah.
So Redux offers like a Dart package?
Absolutely, yeah, there's a Dart Redux package. right.
And so you're saying, when his question about are all those boxes in your diagram for the asynchronous, even the, like,
No, okay. I didn't say that right, if that's what I said. I didn't mean that. Because, right, a lot of that is in fact synchronous. It could be built asynchronously, but it's not. It's synchronous.
okay,
Yeah.
okay. And so that Redux model is a part of the Dart binding for Redux?
This.
Sorry,
Oh, in the code?
yeah, my question about this synchronous part was really for the reducer, where usually that's synchronous.
That's right.
Okay, but that Redux model class, is that part of the Dart binding in Redux? Or is that something you wrote?
That's something that you write.
Okay.
Exactly, right. So in this case, for this page, because I'm going to go to another one, and if I have time, right, it's just a list of counter objects. And what I'll do on the next page is, and I should say again, this was written by Andreas Bizzotto, who I just really like this example. But on the page that I did, I'm just having it be a map of string to string, and the model holds that. Sir?
So part of it's synchronous and part of it's asynchronous. Then my question is, like on that reducer, is stuff coming back from the middleware to the reducer? Is that an asynchronous channel or a synchronous channel?
The middleware out to the outside world is definitely asynchronous. The middleware to reducer really is just another action, right, again, and so it's synchronous. Yeah. Any other questions? Okay. So I think that's enough about Redux, unless there are other questions. Redux per se. And I was going to belabor the point and go through all the things that I just told you on that loop. Does anybody want me to do that? To hammer it home, or would you rather go have dessert? Yeah, okay. Okay, so I'm not going to do that. But it was all nicely color-coded and everything. Sorry? Which? It's very different now, except for the Redux one. I took all these others just to use, because he had his 4 different state management approaches, and I just took it. But this is the easy part. I think Redux is the hard part. I mean, just to grasp it and to buy into the idea that it's worth all that boilerplate and all that work. There is a generator out there to set up a Redux object in Flutter, so you don't have to do a lot of the boilerplate. I haven't used it. Okay. All right, so the next thing I wanted to talk about, and the last thing I want to talk about, and not a lot, is RX, or ReactiveX. So many of you may already know about RX language extensions. There's RX Java, RX Dart, obviously, RX Swift, RX, just about everything has been RX PHP. And basically what they do is they just bring ReactiveX chainables to object-oriented programs so that you can use a very functional programming sort of style. And it's sort of observer and iterator patterns on steroids, all right? But they allow you to do some really cool things. In Dart, since streams are already native, it just extends the Dart streams to give you new operators or methods that you can use. So the nice thing about this is being able to compose, I'm calling them chainables, that's Scott Vlashen's suggestion rather than using the word monads, but is that you can put together a pipeline that massages, changes, does whatever to your state, and so what you want pops out the other end, and you never expose all those intermediate changes. The other thing is these ReactiveX, all the different operators, have really been built on and done by programmers who know what kind of problems you're going to have to deal with, okay? So I just wanted to take a little bit of time to go through and give you an example of some of those. And I think this works better if I actually use my phone. Okay. So what I've done is set up this cloud store to take two inputs from the app, a letter or a number. And they're just going to cycle A, B, C, or 1, 2, 3, 1, 2, 3. So I'm trying to make it very simple because I can't cope with more than that right now, all right? What's going to happen then is that Firestore is going to send that letter or number back to the app, and then I'm going to process those through, I don't need to show you that, I'm going to process those through a variety of these chainables. I think it's in here. Oh, no, it's in the database. Okay. All right. So we're in the middle of the database at this point, where we're getting back the streams from Cloud Firestore. And I can prompt that simply, like I said, by tapping on and hoping and praying, yeah, again, that it will change. So you can see that even though I'm actually tapping on my phone, you're getting the changes in the simulator. All right? Now, so the first two are going to be really simple, and that is I'm just going to take in the number that's coming back or the letter that's coming back on those streams, and I'm going to send them through. I'm going to map them so that they have a title, and then stick that, update the state, put it in the store, and then it winds up on the screen for display. So the first two things, and this one that I've put on the front, and two and so forth, was just so I could keep it in order. I'll trim that off so that all you see here is just num or letter or whatever, okay? So the values that you're seeing in this column are based on, that's hard to make it see, are based on what's coming through those streams, right? So I can whip, chop, puree, and all that kind of thing. So if I type next number, it goes to 2, and that's what you see in that first line, next number 3, next number 1. All right, so that's just basically the raw stream that's coming in. Same thing with the letter, okay? So race, what's race? A race, and it's set up here. Can you all, yeah, okay. A race means you can give it multiple streams, and so I've given it here two, number stream that you just saw, and letter stream delayed, and I'll explain that in just a second. Give it streams, multiple streams, and whichever one answers first, that's what it's going with for the rest of all time, okay? So basically, if you're not sure what your best data source is going to be, but it's in a couple of different places out on the web, this would be a good way to filter, essentially filter out the slow ones, or at least get the fastest one, but then you're stuck with it, like I said, for the rest of all time. So now I can actually, well, I'll show you. So race, you see it shows 2, and the reason for that is even though I've combined the number stream and the letter stream, I used a delay operator in the middle of the letter stream, so it's held back by 2 seconds because I was sure 2 seconds would be plenty on a good internet connection, okay? And so it's going to get there slower than the number stream, and now that's why every time I hit the next number, the race is just going to show the number. It won't show the letter stream. If I delayed the number stream, it would only show the letters as they came across. Okay, so, and that's cool, and that's done, you know, basically right here. It's not much code to do that. Another very simple thing is that you want to bring in 2 different streams, and you just want to handle each event that comes in on either of the streams in the order that it comes in. Okay, so that's called a merge. So here's merge. I'm going to hit number, well, actually, if I leave it like this for a little bit, you can see whether a number comes in or a letter comes in, and no matter how many of either come in, you're going to get the merge output is just going to be the last thing that came in on either stream, right? Again, you can imagine doing some of these things in other ways, but this can get really Baroque, and I'm not going to go all the way to, I'm not going to go for Baroque. Wow. I only said that because Mark's in the audience. Okay, so zip2. Now, zip2 is a little bit more complicated. I am having troubles with this. Okay. Zip2 is going to take one from each of the streams that you put in, and you can put in up to 9. You could combine 9 different streams with zip. And it's going to take the first one from here and the first one next and the first one from the other stream and zip them together, okay? But then it gets a little bit trickier, so I'll show you what happens. So right now it's showing 3 in C, and that's what's on the numbers above. Wow. Okay, and you'll see the numbers are changing, but zip2 is not changing. And that's because zip2 is going to match up one from here and one from here and put them together. But if another one comes in on this stream, but one hasn't come in on this stream, it can't put them together. It's waiting, so what it's going to do is show you the next one from each stream. And basically what it's doing, it's buffering the input until it gets an input from the other stream, okay? So now if I hit letter, you can see that zip has gone to A, 1A. I've hit another letter, it had saved the 2, so it puts it together with the B, C, A. Okay, there were a bunch of, oh, that's right, I hit numbers forever, didn't I? So it has buffered a bunch. If I keep hitting letters there. Now I've run out of numbers. So even though I'm hitting letters and they're coming in, I need numbers to change zip to. Okay, so it's a way to keep things in sync on 2 different streams. All right, so that's useful. All right, debounce and throttle. Oops, throttle. Do similar but sort of confusingly different things. So, best way to do it is just by example. So here's debounce and throttle. And you see, all right, so I'm listening to the number stream, and I'll hit one number, and you see that they're both the same. Okay, I just touched it once. I'll touch it again, wait, because debounce is going to wait for, and I've programmed in 1.5 seconds until it is going to now pass that through the stream. So now if I pass, I'm going to tap twice quickly. Well, I thought, yeah, okay. See? And let it settle. I'm going to tap number twice quickly again, okay? And see what happens. So right now, number is 1, right? Because that's what is in this race, and it's always 1, so you can see that. So if I tap twice, it should go 2, 3. So 2, 3. Wait for it to settle down, and you see throttle's a 2, debounce is a 3. Because what throttle does, it takes the first thing that you entered in a particular time interval and ignores everything else. Debounce takes the last thing you enter in a time interval and ignores everything else. And debounce makes sense. I mean, it's a term from old switches, where mechanical switches, where you turn them on and you get this huge spike. And you probably don't even know that you get a huge spike in the current, or at least in voltage. And so debouncing meant sort of ignoring this first stuff and just taking that sort of planed out value. Okay. So that's where the name came from. All right. And then one more, and I'll say this, there are a ton of these different operators. There are so much, and there are a set that are really worth learning, but they're tricky. They're exhaust map and merge map and these things that basically you use to have one stream control another set of streams. So you're turning streams of streams and, whip, chopping, puree, whatever, all that sort of thing. So distinct, unique. All right. Let's see. Oh, I'll have to reset state. So what's different about this is I'm not holding state in the cloud, I'm holding it on the two phones. So if you could see, well, for example, on my phone, zip2 is 3C, and on the emulator it's 3A, because they have different histories that I'm storing locally. All right. So right now, distinct unique is 3 on here. If I hit 1, it goes to 1. Hit 2, it goes to 2. I hit 3, nothing. If I hit 1, nothing. So distinct unique just keeps track of what's come down the stream, and it only passes it through if it's something you've never seen before, right? Which, I mean, you can think of how you might use these things, but if you have these things in your tool set, then you have ways to handle asynchronous streams of events in ways that would just all but be impossible if you're using sort of straightforward imperative code. This functional programming approach makes it not just doable, but actually kind of fun. But again, it's like Redux. It takes a little bit of warming up and learning. And it's the kind of thing that if you write a little program like this, it helps just to sort of exercise it and work it through. All right. So, end of the talk. Why Flutter? Why Dart? Why functional programming? Basically because they're all, especially Flutter and Dart, I'm not sure I would call functional programming friendly. It is once you get used to it, and then it's, like I say, it's really fun. They're all fun, they're all powerful, and I think they're all pretty forward-looking. So I highly recommend all 4, and I'm happy to take any more questions. Sir? I'm sorry, say it again. Create React app? No.
It's like a tool to create a React app really quickly with best practices and stuff. So
Okay.
I was wondering if there's a similar tool for the Flutter Dart combination.
Yeah. So the question is about whether there's an easy way to set up basically a template for setting up Flutter apps that embodies best practices. Flutter's new. I'll start with that, and that is what best practices really are, like for state management. The Flutter team is very unopinionated about that. You're left on your own. But what there are, Brian Egan has a GitHub repo where he takes each of these things, different state management, just different whatever, and writes what is a very nice app that uses best practices for each of those so that you can go in and actually learn how to do it from reading those. There are, like I said, generators and templates that have been provided by the community, not by the Flutter team that I'm aware of, that will set up apps for you. And in fact, when you first set up a Flutter app using one of these IDEs, it comes in with counter app, not with the Redux encounters, but with counters where just if you hit this button, it'll increment or whatever. The way this is set up is actually add a new whole counter, not just to increment the value. Anybody else? Sir?
So in Reason, whenever you refresh the view, whenever you make changes to the view, it does like a buffering strategy, and it like doesn't open the new view. Does Flutter do something like that, or like how does the view actually get rendered?
Okay, that's a really good. So the question is, how does the Flutter view get rendered when you've changed state in some way that it needs to change for something on the screen? Flutter is reactive, okay? So you never actually tell it, once you've set up your widget tree, described how you want state to be shown on the screen, then basically you just change state and that changes the view on the screen. And there actually is a set state method in what are called stateful widgets, so meaning they hold state locally. And then you can just manually, anytime you change something and you want to change the view, then you just call set state, and then it'll re-render everything that's dirty. Now, the reason I say that is, I kind of want to talk about this a little bit. The widget tree is really a blueprint of immutable widgets. Every widget builds an element, so there's an element tree, and every element actually builds the render object, which is what really gets shown on the screen. So what Flutter does behind the scenes is, if state changes, then it marks, I think, elements as dirty. On the next pass, so at 60 frames per second in the next 16 milliseconds, it'll recognize that. It'll rebuild only those elements that need to be changed, right? And then render those on the screen. And so that's part of how it's fast. Anybody else? All right, well, thanks.